Yeah, hello again. This is a solar video again because many people still ask me how is the solar plant doing, how is the parts doing, and can you give us any observations you made and tips you have. So let's start from the beginning. I installed 4 kilowatt of power on the roof of my neighbor, and you can see this in the short intros I show you here. So it's 8 panels, 500 watt each, and I planted there because this roof is big enough to hold 8 panels. Maybe in the future I can install 2 or 3 more, but the roof on my house would be facing to sunset and is way smaller, so it does not really hold all the 8 panels. So from this set, my panels now face sunrise. That gives me a lot of energy in the morning until 12, 1 p.m, 2 p.m, and then the panels go into the shadow, but it's not that bad until I would say 5 p.m. I still have enough power to power a regular house if I wouldn't use my air cons. And you can see this also here in a typical chart over a day, where you can see there is a steep incline in solar production in the early morning because the panels have no shadow. So if it's a sunny day, the sun directly powers them nearly to full extent. The last weeks it was a little more cloudy, but even that way I can still generate 2 kilowatt, 50% of the capacity on a cloudy day. If it's really raining and you have a thick cloud cover all day long, then the generation really goes down. Then maybe the plant will produce only 4 or 5 kilowatt per day. But if it's a regular cloudy day with sunny parts, or even a sunny day with only some clouds, then my 4 kilowatt panels can easily generate 20, 25 kilowatt or even more per day. I cannot really measure how much it will be because I just miss the possibility to store the energy. I will explain net metering and why I don't do this in a follow-up video in some weeks, because I need to do some research for this. Okay, here now I show you my electric bill for the last years, and you can see that I usually have 450 to 500 kilowatt per month. So if you just calculate with 550, it's easier because you just divert this by 30 days, and it gives you that you need around 15 kilowatt per day of electricity. And if I now show you my last bills here, that you can see the plant was installed end of March 2022, and in April there's still the same amount of usage because we had a lot of rain in these months, so the plant didn't really generate power for 1 week. But as you can see, in May it directly drops, and now in June I had just 27 kilowatt of power that I used from Weco, and the rest was done completely by the plant. And to further check how much power your appliances use, you buy yourself a power monitor on Lazada. This one is about 900 peso if you buy it. I put the link into the description, and you just plug it in and it directly shows you how much power your appliances use. So this is showing my computers here, and they use around 150 watt per hour, but it can easily also go up to 200 and 250 watt if I work from home here and use my PC and the second monitor too. What is usually using a lot of power? We all have a fan, but fans usually run around with 50 watt per hour. That's not really typical much. Then you maybe have a ref, but if your ref is a modern one with an inverter, you will notice that when it's idling because it is cooled already, then it's idling and using maybe 20 watt only. So a refrigerator really is not using a lot of power. Also aircons, if you have a standard aircon with no inverter, the standard 1 horsepower window type, you can say this one uses around 800 watt per hour. So this is really needing a lot of solar panels. But on the other side, if you switch to an inverter type aircon, maybe a split type like I have, then you will notice these ones really don't use much power, and I will show and explain this to you later when I explain it with the Solarman app, how the power generation is done. What really uses a lot of power in the house is everything that heats up water. So if you have a water cooker or even a rice cooker, this really draws a lot of power, because heating up water needs a lot of energy. Also, if you are running a water pump, my pump is maybe 0.5 horsepower only, but if it runs, it uses 500 watt. And if, like mine, it's not really proper working anymore, so it is always running, and combined with our washing machine, it then really can go up to 3 kilowatt when I do the washing, because the pump is running, maybe one aircon is running, and the washing machine is heating up the water. And the next thing that you might also think about is, at the moment I still have the gas cooker because the gasol is still full, but now I have the electricity from the solar. So in the future I will change to an electric stove, because then I have free electricity. Why should I now buy the expensive gas when I have free electricity? You also have to consider the time when your house needs the electricity, because what we all now know is that it's cooler in the night and in the morning, because there is no sun heating up the environment. And usually in the early afternoon and late afternoon and early night, there is the most heat that needs us to run the aircons. So like me, if your panels is facing to the sunrise, then you generate most of the power, but you don't need it. And in the evening, when you really need the power, the panels are in the shadow. I can overcome this by installing the battery, because later then the battery kicks in and gives all the power we need. But if you don't have a battery, like I mentioned in the beginning of the video, you should consider placing your panels to the sunset, so that you can get the power from the setting sun longer. Yeah, now I show you here how the plant is working. We see the inverter in the center, the heart of the system, and still at around 3:30 p.m. we generate around 900 watt, which is enough to power the house here, 750 watt. So the house usually runs with about 200 to 250 watt consumption for the appliances. Then my computer needs maybe 150 to 200 watt at the moment, and the rest is due to the aircon. Unfortunately, my office room here is hit by the direct sun in the afternoon, and this heats up the back wall behind me and so the aircon in the afternoon has to run harder to cool the room down, because I didn't account for that I have a nearly 3 to 4 square meter wall. That works like a heater. What you cannot see is the amount of power the inverter needs itself. That's between 50 and 100 watt. But you can also see I don't use any grid power from Weco, because the solar generation still is enough to power the house. Now let's scroll down to see how the power generation today was. And as it is a cloudy day, you can see there is always steep declines when there is a cloud coming in front before the sun. But you can also see that early at 6 o'clock here here is already 500 watt when we maybe have 8 o'clock, but it was cloudy. If I now go to a different day, yeah, yesterday it was even more cloudy. The total generation over the day was 14 kilowatt, and you can see here it is very cloudy. But if I go back here to a day where it was really sunny, then you see it really goes up very steep. If I say here maybe is around, this is around around 7 o'clock or shortly after 7, I already have 1 kilowatt of solar power. And if you now look, I overlay the consumption that I have. Now you see how much I consume. Then you see this is the consumption. Unfortunately, this scale is not aligned with this scale. Well, now it is aligned, that's great. Usually it's not, but you can see that I have a consumption about maybe 350 watt here coming over from the night, and around 6:30, 7 o'clock the solar panels already produce enough energy that my usage is covered, and all this which is here more is the overproduction. All this goes into the battery, and then you can see now I switch the power generation off. Now you see I get up, I use the water heater, have breakfast, and then 2 days ago I washed my clothes, so you can see it's really going nearly 3.5 kilowatt when the washing machine is running and heating, and then I take a shower, so the water heater in the shower, and the 5 kilowatt inverter is easily coping with this. And as you also can see, the power generation is enough. So the solar power is still around 3.5 kilowatt, and there is no problem that I use all my appliances. All this is done easily with the generated power from the power plant. Then later here I work a little bit in my office, and then I have a rest, and then later here you can see this is when I work at home here in my office, and I use the aircon here, and as I mentioned before, the wall in my back is really heating up. That means, and the computer is fully running here, so I really need about 700 watt per hour to power this. And then you ask, is this enough? How much power do you need, or how much battery do you need? Now I switch to the monthly display, and you can see this is the generated power, generation from the solar plant, and this is now the month of July. So we are on the 11th, and you see, because it was raining, I usually generate around 50 kilowatt per day. But as I told you, I cannot store in the battery all the energy I produce. If I go back now here to maybe, this is June, and you see I'm around 16.7 kilowatt. And if I go back to May, when I used even more power, I generate 19 or even 21 here. So you see at the moment, because it is a little more cloudy, and as you know, my girlfriend left, so I alone don't use so much energy, so the consumption goes down. And as I explained, I have a 10 kilowatt battery which I can use about 8 kilowatt. Now I can show you, this is the generation of the power plant over the day, and now I show you how much the battery is adding to this to get me through the day. And this charts is not the same. So here you see the generation power, the blue one, this is the chart here, and the maximum is 3.8 kilowatt. But the battery here is this charge, and this is nearly maybe 901 kilowatt, so usually is only one. But what you can see is during the night I'm powered by the battery, and the peaks is always when the aircon is needing more power. But usually during the night I use maybe around 1 kilowatt. This is due to the aircon running, the inverter running, and maybe the basic appliances running. And then you see here around 7 o'clock, when the solar generation is high enough, the battery shuts down. But you see here in this moment, usually it drops down to 0, because now the battery gets charged and the house is powered completely by the sun. And only here around 5 p.m. when you see the solar generation goes down, then you can see the battery is kicking in again. And then you see here is a peak from the aircon, then it goes down, and here it starts again using the battery, because I was working, so I use 800, 900, nearly 1 kilowatt here for the battery, and this gets me through the night. But what you can see is there is no real usage of Weco, because this, if you just see, this is maybe 800 watt in maximum, and if I would draw a line here, then I use about 7 hours 500 watt here. This is 3.5 kilowatt, and here I maybe use for about 6 to 7 hours the same. So this is also maybe 4.5 kilowatt, but in the end the 10 kilowatt battery is enough. And now I show you a different day where it was even more cloudy, and you see the overall production was just 10 kilowatt on this day. And you see the solar generation is really just a little bit over 1.7, 1.8 kilowatt all the day long. And here during noontime, it was this day with heavy raining, and there is maybe 500 watt generated. And this means I don't really have enough power to charge the battery. And then if I check how much I use from Weco, you see I use power that comes from Weco in the morning, because the battery here was empty. So I used a little power by Weco. Then the power from the solar plant is still enough to run the house and charge the battery, but later the night the battery capacity gets empty, and then the Weco kicks in again. And if I go to the next day, then you can see that the on-grid power, this is coming from Weco, because the battery was already empty the night before, here, and so I run the night with Weco. But how much is this now? We are now around 20 minutes later in the video making, and you can already see the generation is down to 650 watt. The house is still using 750 watt. So instead of using the grid, the inverter now uses the battery, and it's just drawing 220 watt, 250 watt from the battery. And the more this generation decreases, the more the usage of the battery will increase. So in the end, the battery will be used by maybe 800 watt per hour. But as long as the battery is powering everything, I don't need the grid. And if you know the battery runs with usable about 8 kilowatt or maybe 8.5 kilowatt, then even I draw 800 watt here from the battery, this will last for 10 hours. And if I now go down here and show you the energy I bought from Weco over the last days and weeks, then you can see I really don't need much grid energy. So this one, first day of the month, second day of the month, here it was very rainy, but I maybe used 2 kilowatt only from Weco. This is until now July 11, and you see there was 2 days where I did not get any power from Weco. If I go back to June now, this is the generated power, so I now show you the board. Then you see in June I didn't use any power here from Weco, and there I used maybe 1.6 kilowatt. There it was a little more rainy, so I needed more, but at all this is maybe 15 or 20 kilowatt only. You can also see this in the monthly bill. I show you my last monthly bill was just 27 kilowatt used, and Weco always bills at the 15th of the month. So my last bill was this period here plus the last of May. So the next question you might ask is, yeah, does this calculate for itself? What you need to see is that solar panels are really long living. Solar panels have no mechanical parts that can fail. This is like a crystal that is generating solar electricity. And if you buy high-class panels like I did with Trina Solar, then you can say the degradation of a panel is less than 1% per year. So with my 500 watt panel, after 1 year, each panel should still produce 495 watt. So in the Solarman app, I will not see any change. I think in next year that there is already the panel starting to degrade. Maybe in 10 years I will notice that my plant is not generating 4 kilowatt anymore, but maybe only 3.6 kilowatt. But then we talk about in 10 years. And in 20 years, the plant will still generate 3.2 kilowatt. So this is 20 years from now, then I would be 77. And this is what you have to consider when you buy solar panels. They last really, really long. They are something you inherit to your children and grandchildren. If you buy solar panels, they stay on your roof of your house for maybe 30, 40, 50 years, because as long they don't get physically damaged completely, they still generate power. And with a degradation from maybe 1% per year, you can say that a 500 watt panel will generate still 250 watt in 50 years. So your grandchildren still have something they can use in 50 years to generate electricity. So solar panels are really cheap if you look it in the long run. The next part is the inverter. I use the DEYE inverter because it is well known here and everybody tells me it's a good brand. DEYE itself gives a 5-year warranty on the inverter, so I hope they have built it with high-class parts. But usually it's electronic, and you know, one day it works, next day it's busted. So I cannot really say that it degenerates or produces less electricity. It will work and work and work, and one day it will fail. I have a water heater for my shower from a German brand AEG, and this is now 8 years working and running, and there is no failure. So I hope that my DEYE inverter will last at least 5 years, and if I'm lucky it will last 10 years. And then I say, for a buying price of 50,000 peso, this is 5,000 peso a year when I calculate for 10 years. The only part I cannot really say anything about is the battery. The problem is you don't find any reviews for Bluecarbon batteries online. There are rumors that Bluecarbon is using already used lithium iron phosphate cells, but lithium iron phosphate cells are really made for thousands of charging and discharging cycles. And as you can see in the charts, usually even if these batteries are used cells from the manufacturer BYD, then they might live for 5,000 cycles. And if they have been used for 3,000 cycles, which would be around 8 years already, then they still have a life expectancy of about 2,000 or more cycles, and this is 5 or 6 years. So from the capacity of these cells, I would say they still have 5, 6, 7 years where they live and give me a good capacity. As I don't use the battery to the maximum at the moment, I use only 8 kilowatt. This prolongs the lifespan of the battery itself. So I would say maybe after 3 to 4 months I cannot see any degradation of the cells and of the capacity of the battery. Maybe I can see something in 2 years, so please switch back to my channel in 2 years when I give you an update on the battery. But from the physical and chemical part of the battery, I would say if after 5,000 cycles the cells still have 80% capacity, this would mean that from the 10 kilowatt I bought, I still can use 8 kilowatt, and if I use maybe only 80% of this, it still is a battery that gives me 6.5 kilowatt, and this is maybe in 5 years time. Yeah, if you consider all this, then you can say a solar plant is a one-time invest, but it will last at least for 10 years. If I say that maybe the inverter fails after 10 years, but maybe in 10 years we have much better inverters, so I can replace this. And even if the battery lasts only 5 years or the capacity goes down, then I can still think about I use what's left. Maybe there's 5 or 6 kilowatt capacity still left I can use, or I sell it and buy me a new battery, but this is maybe in 5 or 10 years also. And for the panels, if you buy branded panels, then you just put them on the roof and forget them there, because if there's no physical damage, even your grandchildren will be happy to have them. And so the invest of 300,000 pesos I did, I will have back in maybe 7 years, considering that I save 4,000 peso a month, and after this I really generate electricity for free. So yeah, I hope the video gave you insights and information enough for your own solar installation. I will do the update video about net metering and also maybe how to start small with the inverter and the panels and upgrade with batteries later in the follow-up video in some weeks. Don't forget to like and subscribe my channel so that you don't miss the upgrades I will do. And bye bye for now, and see you soon.